At absolute value inequalities, there's two scenarios that we're going to take a look at for absolute value inequalities. And that first one is the absolute value is less than a value, or where did I put it? It's right here. Absolute value of x is greater than a value. So let's first look at the absolute value being less than a number. So in this first example, we have the absolute value of x being less than or equal to 3. So before I just throw out a rule here, I want to talk about this more from a logical standpoint and just understand what we're actually looking at. Because if we're talking about an absolute value is the distance from 0. So if I take the absolute value of negative 3, that's 3. Or if I take the absolute value of 3, that's also 3, because it's the number of units away from 0. So if I want to identify what all of my potential solutions are in this first inequality being less than or equal to 3, it could take on a number of different values. Like, for example, one value that it could be is 1. The absolute value of 1 is 1. 1 is less than or equal to 3. What about the absolute value of 2? The absolute value of 2 is 2. 2 is less than or equal to 3. 3. 3 is equal to 3. That is less than or equal to 3. What about 0? 0 is... the absolute value of 0 is 0. 0 is less than or equal to 3. But what we also want to keep in mind is that all these statements are true, 0 through 3, but what about the negatives? What if I start including negatives, like negative 1? The absolute value of negative 1 is 1 less than or equal to 3. Absolute value of negative 2, that's 2, less than or equal to 3. So we also have to include the negatives. But we have some boundaries that we're going to fall under, because if I start going past, so like I said, absolute value of 3 is 3, 3 is less than or equal to 3. Once I get past a certain point, though, where let's say 4, absolute value of 4 is 4, 4 is not less than or equal to 3. So 4 we go over, 5's over, 6 over, 7 over. Same thing on the other side. When I get to negative 3, that's 3. 3 is less than or equal to 3. But once I get to negative 4, that's 4. 4 is not less than or equal to 3. So we fall into this limitation between two certain values. So that's kind of like a rule here. Whenever we are, and I'll come back to this actual solution for number 1 in a minute, but whenever we are looking at the form of absolute value of x is less than a, we take the negative of a and put x between a and negative a. So x is going to be between those two values. And if we have some sort of like equation that we have to solve, but that's what's we're going to form a compound inequality. So the solutions for this first one that I was doing is going to be from negative 3 to 3. It's going to be any value between negative 3 and 3. And the reason we're including 3 and 3 is because we have the absolute value of, or we have the inequality of less than or equal to, meaning we're including. So it has to be between negative 3 and 3. So this is the first rule that we're going to use for this form, is setting it, take that expression and put it between negative a and a. So number 2, we have the absolute value of x minus 8 is less than 8. So first of all, the absolute value is by itself. That's one thing that you want to keep in mind. The absolute value has to be by itself. And then now what we do is we form a compound inequality where I put this between negative 8. So x minus 8 between negative 8 and 8. And then I just solve. And with this one, it's a pretty straightforward solving. So I'm just going to add 8 to everything. So I get x is greater than 0. Negative 8 plus 8 is 0. 8 plus 8 is 16. So x is between 0 and 16. And that's going to be parentheses 0 and 16, because we don't want to include, because this is strictly greater than 0, strictly less than 16. So we do not want to include 0 and 16. Let's look at number 3. Absolute value of 2x plus 3 is less than or equal to 13. So we're going to put that in the absolute value is by itself. Make sure you always identify if the absolute value is by itself, meaning I don't have like this. Like let's say we had 2x plus 3 plus 5 less than or equal to 13. You'd want to get that absolute value by itself, but we don't have that. So we're good to go with just putting it between the two values. So we're going to have 2x plus 3 is greater than negative 13 and less than 13. Once we identify that, we can solve, and just to save some time on this video, I'm going to just solve these both at the same time here. So negative 13 minus 3 is negative 16, and we get 2x. Less than negative 13 minus 3 is 13. Or I'm sorry, not 13. I was thinking 16. Minus 3 was 13, but it's 13 minus 3, so that's 10. Excuse me. And this is or equal to. Forgot that, right? Yeah, or equal to. And then we want to divide everything by 2. Negative 16 divided by 2 is negative 8, less than or equal to 2x over 2, left with x, less than or equal to 5. So x has to be between negative 8 and 5, and those are both going to be brackets because we have the inclusion of the endpoints there, so negative 8 to 5. And we could be graphing these also, but I'm just trying to save time where I can, and so these videos don't get too out of hand, especially if it's content that we've looked at before. So if I want to be between negative 8 and 5, I'd have negative 8 and 5, and we can put brackets and then just highlights between. So our solution would be between negative 8 and 5. Here I'd have between 0 and 16, so here's 0, here's 16. And I'd use parentheses, and then I could highlight between 0 and 16. We're forming that compound inequality, so we're looking at that word and, where it makes the two statements, so the overlap, if we were to actually graph these out completely, but that would be our solution. So number 4, we have the inequality of x plus 7 less than or equal to, the absolute value of x plus 7 less than or equal to 17. So this one's interesting because we don't have the x by itself, so we have to take that step to get the x by itself. So we get the absolute value of x less than or equal to 17 minus 7 is 10. Then I have the absolute value by itself, so now I could form that compound inequality where x is going to be greater than negative 10, x is going to be less than 10. So we have x between negative 10 and 10, and if we want to graph this, we put negative 10 here, and those are, I keep forgetting the equal to cents. So that's going to be between negative 10 and 10 with brackets because we want to include the endpoints there. So then I'm going to highlight between, and then the interval notation would be from negative 10 to 10, with both being brackets. Good examples there. Let's move on. So now we're looking at a couple different potential scenarios. On this next one, we have the absolute value of 2x minus 2 is less than negative 10. So less than negative 10. Thinking about this, on the last couple examples we had less than positive 8, less than or equal to 13, less than or equal to 17. So we're dealing with positive values. And in this scenario, if we think about just from a logic standpoint, if I want to take the absolute value of a value, like if I take the absolute value of x, and I try to make this less than some negative number, so let's just use negative 10, there's no way that I could get the absolute value of a number to be less than negative 10, because when I take the absolute value of negative 10 or anything, negative 100, positive 100, it doesn't matter, it's going to be a positive 10, positive 100, positive 100. So I'm not going to get this answer where I'm getting an answer less than a negative value. So in this case, when we are taking less than a negative 10 or less than a negative, we're going to have the empty set. We don't have a solution for that. So no solution, the empty set, a couple of different ways to identify that. So if it's less than a negative, you can't do that. Now, the reason I was able to make this conclusion, though, on this one was because the absolute value was by itself, and then I identify, well, this is less than a negative, I can't do that, so then that's no solution. Where on the last one, or the next one, excuse me, absolute value of x minus 5 minus 7, less than or equal to negative 1, you see how the absolute value is not by itself yet? I have to go ahead and get the absolute value by itself. So now I have the absolute value of x minus 5 less than or equal to negative 1 plus 7. 7 minus 1 is 6. Now I have the absolute value less than or equal to a positive value. Now I could take the same steps that I've been doing where I get the absolute value by itself. Or I'm sorry, not the absolute value, but create that compound inequality. So x minus 5 is greater than negative 6, less than positive 6. Then I add 5 to everything. So that means we're going to get negative 1. X is greater than negative 1 and also less than 11. And this is or equal to. Keep on dropping that or equal to. So both brackets. highlight between -1 and 11. And then we're going to have bracket -1 and 11. Next form, solving absolute value inequalities of the form absolute value of x greater than a. So in this case, we want it to be greater than a value. So if I were to think about, let's say I had the absolute value of x, let's use this example here of greater than 6. Think about the x values that are going to be greater than 6. X values greater than 6 are 7, absolute value of 7 is 7, 7 is greater than 6. Absolute value of 8, 8 is equal to 8, greater than 6. You could think all day, because there's an infinite number of values that are going to be greater than 6. 10, 11, 12, 13, 100, 200, 300, 1,000. There's an infinite amount of possibilities, on that end at least. So if I were to think of this on a number line here, 6, any value greater than 6 is going to be a potential solution. What about, though, on the negative side, just like how we discussed on the other inequality, where we were looking at negative values? What about the absolute value of -7? The absolute value of -7 is 7. 7 is greater than 6. Absolute value of -8, that's 8. 8 is greater than 6. Absolute value of -9, that's 9. 9 is greater than 6. Same thing's going to happen. We're going to get an infinite number of solutions on the negative end, because those can also be bigger than 6. So once I get to that -6, and again, -6 doesn't work, because -6 is equal to 6. We want it to be greater than 6 in this case, in this example. So that's not true. -5, not going to be, -4, and so on. But once we get to that mark of -6, all of these values over here are going to be solutions. All of these values over here are going to be solutions. So we're getting this type of inequality where we have these two potential solutions on either end. So in this case, whenever we have this scenario where we have the absolute value of x being greater than a, we want to take the x value and set it less than -a, and the x value greater than a. Because then the reason we're setting x is less than -a, because if I look at this example here with absolute value of x being greater than 6, if I take x less than -a, x can take on any, not -a, -6. X can be any value less than -6, just like how I said here. -7, -8, -9, -7, -8, -9 are all values less than -6. So it could be an infinite number of solutions there. And then same thing on the other end where x is greater than 6. So in this case, we get an or type of inequality, where the last ones we were looking at, we create a compound inequality where we have the word and, because it has to be that overlap. But here it could be or, it could be any value less than -6 or any value greater than 6. And I already drew this out on the number line right here. I just use this as my example, but let's go ahead and create the interval for this one. So the interval would be from -infinity to -6, unioned with 6 to infinity. And the graph is this line right here that I made right there. But number 8, the absolute value is not by itself, so I have to get that by itself. So we're going to subtract 7 from both sides. I get the absolute value of x is greater than 8 minus 7 is 1. So now the absolute value is by itself. It is a greater than value. So we are going to take x and set it less than -1. We're going to take x and set it greater than 1, because it could be -2, -3, -4, -5, because the absolute value of all of those numbers are going to be a value greater than 1. So on a number line, -1, we have 1. So from -1, it's going to be all the values to the left. From +1, it's going to be all the values to the right. And then it is an interval notation. We're going to go from -infinity up to -1 with the parentheses, because we want strictly less than. And then we are going to union that with 1 going out to infinity. So the two different scenarios, very important that you understand what we're looking for, because it could be two different types of solutions. I think I have a couple more. Number 9, the absolute value of 9x is greater than negative 5. So if we think about how to solve this one, we want it to be greater than negative 5. So if I just start thinking about, well, what are some values that could be greater than negative 5? What if x equals, let's say, 0? That would be the absolute value of 9 times 0, greater than negative 5. 9 times 0 is 0. 0 then 0 is greater than negative 5, yeah. What if it's like negative 10, let's say? I like to try to jump around with the positive and negatives and see what we get. 9 times negative 10 is negative 90. Absolute value of negative 90 is 90. 90 is greater than negative 5. So what do you notice that's happening here with these values being greater than a negative? There's really no end to the potential number of solutions that we get, because no matter what I put in, it's all going to be true. I took a negative, it was true. I took 0, it was true. If I take a positive, same thing. If I took 9 times 10, absolute value of 9 times 10 is 90. Whoops. That's 90. 90 is greater than negative 5. Those are all true statements. So the solutions here are going to be from negative infinity to infinity. There is an infinite number of potential solutions because we're greater than a negative value. No matter if we take the absolute value of any number, we're going to at least get 0 or a positive. So they're all going to be true for that. So negative infinity to infinity. So let's take a look at a couple more. We want to subtract 4 from this one. Let's get the absolute value by itself. So I'm going to subtract 4, get the absolute value of 6 minus 11, greater than 11 minus 4 is 7. Absolute values by itself, what are we looking at? We're looking at a greater than scenario. What did we talk about for greater than scenarios? When it's greater than, we said x is less than the opposite of that, so negative, and then we said x is greater than that value. So we are going to say 6x minus 11 is less than negative 7. And then we're going to say 6x minus 11 is greater than 7. So let's go ahead and solve these. I'm going to add 11. It's 6x less than negative 7 plus 11 is 4. Divide by 6, x is less than 2/3. 4 over 6 is 2/3. 2 goes into 4 twice, 2 goes into 6 3 times. And then on this one, we add 11 to both sides. I get 6x greater than 18. Divide by 6, x is greater than 3. So x can be less than 2/3, or x can be greater than 3. So if I were to put this on a number line, here is 2/3, here is 3. So it could be numbers less than 2/3, or it could be values greater than 3. Interval notation, negative infinity to 2/3, unioned with 3 to infinity. And those are parentheses because we are looking at strictly greater than or strictly less than. So parentheses. Number 11, 9 plus the absolute value of x less than or equal to 2. We're going to subtract 9. So we get the absolute value of x less than or equal to 2 minus 9 is negative 7. So we're in that situation where we have the absolute value less than or equal to negative value. Make sure you identify what this actual potential solutions could be. On this one that we talked about on number 9, this was greater than negative 5. Any absolute value I take will be greater than a negative. But here, any absolute value that I take will be 0 or a positive, so they're definitely not going to be less than a negative value. We can't do that. We can't take the absolute value of something and get a negative, so there's no way we could have a solution here, so that's going to be the empty set. And last problem, absolute value of 3x plus 2/3 is minus 9, less than or equal to negative 4. Just the key to this problem here is just making sure you identify that this absolute value is not by itself, so we have to get the absolute value by itself. So I'm going to add 9, because right now it's less than a negative, and you're thinking like, oh, less than a negative. We just talked about that being no solution because you can't have less than a negative, but the absolute value is not by itself, so I have to add 9 over. I get the absolute value of 3x plus 2/3 less than or equal to -4 plus 9 is 5. So now we have the absolute value less than a number. So in the less than scenarios, what did we mention about less than scenarios? That is where we want to be locked between two values, negative a and a. So we're going to take -5 less than or equal to 3x plus 2/3 less than or equal to 5. And the reason I wanted to do this one is because I wanted to talk about the solving here. You could break it up into two different inequalities, but there's actually a little bit of a nice way to solve this, where if you just multiply everything by 3, because I want to wipe out that denominator, actually makes things a little bit easier, because if you don't, you'd have to do 5 minus 2/3. Gets a little bit tricky. So if we just multiply everything by 3, so we get -15 less than or equal to, and then if I distribute the 3 here, 9x plus 2, because 3 times 2/3, 3's cancel out, less than or equal to 15, and then it's a lot more manageable from here. Go kind of quick through the solving here. So -15 minus 2 is -17, less than or equal to 9x. Divide by 9, -17 over 9, less than or equal to x. And divide by 9 on the other one, so 15 minus 2 is 13, 13 over 9. So x is between -17 over 9 and 13 over 9. So bracket -17 over 9 and 13 over 9. Yeah, last one is just dealing with the fraction, is why I wanted to talk about that one. Okay, so we looked at all the different rules for the absolute value inequalities. Pretty tricky. Just make sure you have those rules written down somewhere, so in that way you keep that organized. But it is all dependent on this, the inequality.